All right, let's take a look at number 22. This is actually one of the most important problems really in this chapter. It leads into an idea that we're going to focus on in section 9.3. Because we're skipping around a little bit, we may not see this idea until, I don't know, a week or two from now, but it's a really, really important idea. So if you take a look at this, of course, they tell you that you've got a right angle at ACB. CD is an altitude, so of course you've got right angles at CDA and CDB. If you notice, they're asking you to prove that a product is equal to a product, and that may look a little bit strange to you at this point, but remember that we've got this big idea that if a product is equal to another product, it's coming from a proportion. So this is really just asking us to do a proportion. So I've already set up a lot of this. I'll talk about this in a second. But let's look at this CD squared. CD squared, of course, means you're multiplying CD times CD, and that's equal to AD times dB. Okay, so one of the really huge ideas from this chapter is if you've got a product equal to a product, it's coming from a proportion. So I'm going to fill in a proportion here. I'm going to do a CD in these two spots, and I'm going to do an AD and a dB. I don't think it particularly matters where they go, but maybe something kind of like that, okay? And if we look at the diagram, look at what we've got here. CD is this segment here, AD is that segment there, DB is that segment there, and then CD is that segment there again. So we've got two sides of this triangle, we've got two sides of that triangle, okay? So the big takeaway here is that we have to prove those two triangles similar. Our challenge is going to be that you have a right angle here and a right angle there because of the altitudes, and that's it. We don't have any other congruent angles. We don't have any other shared parts for those two triangles, okay? However, here's the big idea, and this is something that's going to be hugely important in Chapter 9, at least in Section 9.3. We also have a right angle up here. We've seen this idea several times. This idea actually comes up at the end of the Chapter 8 review PowerPoint that you're working on today, if you haven't seen that yet. Notice we have two right triangles inside a right triangle, okay? This triangle here has a right angle, and it shares angle B with the big triangle, okay? This little triangle here is similar to the big triangle by angle. This triangle over here has a right angle, like the big triangle. It shares angle A with the big triangle. So this triangle here is similar to the big triangle, also by angle, okay? And then, long story short, if those two triangles are similar to the big triangle, they're going to share all the same angle measures with the big triangle, and that's going to mean that the two little triangles are also similar to each other, and that's our goal, okay? Our goal here is to show that triangle ADC is similar to triangle CDB. That's really where we're headed. Okay, so anyway, it's relatively easy to explain. If you're doing it as a paragraph proof, it's probably not real tough. A little bit tougher in a two-column format because we're going to have to get the angles paired the way we need them. And probably a transitive property or something make that happen. Anyway, let's look through here. So I already set most of this up to save you a couple minutes on the video, but we've got the givens there. Angle CDA is going to be a right angle because if a segment's an altitude and intersects the side of which it's drawn at a right angle. CDB also is going to be a right angle for the same reason, okay? And I just went ahead and stated that all the different right angles are equal. CDA is going to be equal to CDB, CDB is equal to ACB, CDA is congruent to ACB. You could do a transitive property there and link all of them. Anyway, I just needed lots of different pairs because what's going to happen is we're going to prove, the little triangle on the right similar to the big triangle. We're going to prove the little triangle on the left similar to the big triangle, and we're going to use that to get the angles we need to prove the two smaller triangles similar to each other. That's where we're headed. Okay, so long story short, what do we do? Well, let's focus on proving CDB similar to the big triangle. They both share angle B, all right? So angle B is going to be congruent to angle B by the reflexive property. All right, and so that's going to make those two triangles similar to each other. Triangle CDB is going to be similar to triangle, let's see, CDB, that'd be BCA, I think, is the big triangle. So CDB and BCA, okay? And those are similar by angle, okay? And now I'm going to prove the triangle on the right, this triangle over here, is similar to the big triangle. That's going to be the same thing. They're both going to share angle A, and they already have right angles in common. So angle A is congruent to angle A. That, of course, is by the reflexive property. And let's see now. We can say that triangle ADC is similar to triangle, looks like ACB. That's by the angle-angle rule, so you can see I've got that here. Okay, and now we just need to get some angles paired up. All three of these triangles have right angles, so we just need to show that some pair of angles is equal for these triangles. Let's show that angle B here is congruent to that angle there. That'll give us two angles on the two little triangles, to match up with the right angle, and then we'll be okay. My goal here is to show that I need two angles. I've got a pair of right angles for these two triangles, but I need another pair of angles from these two triangles to be congruent to each other. Okay, so what I'm trying to do here is show that this angle is congruent to this angle here. Okay, and actually if you go back and look at the last statement I wrote, angle C for triangle ADC, you can see it right there. Angle C is in the last position here. When I'm comparing it to the big triangle ACB, you should see here that this angle here corresponds to that angle right there. And you can see that in this statement right there. Those angles are both in the last positions. So since those triangles are similar, I'm going to be able to say that angle ACD is congruent to angle B. Okay? They're in the same spot in those two similar triangles. So if triangles are similar, then their corresponding angles are congruent. Okay? And at this point we're good to go, because these two triangles both have right angles. We already showed that earlier. They have two pairs of congruent angles. So the two triangles are similar by angle-angle. I'm going to say ADC is similar. ADC is going to be similar to CDB if you look at where the short side and where the long side is on the two triangles. So triangle CDB, and that's by the angle-angle rule. Okay, and from here, it's real quick. We just need to set up a proportion that will end up giving us that cross product. So I'm going to do that proportion there. CD over AD is equal to DB over CD. And if you check, those are all sides of the two small triangles that I proved congruent. That's if triangles are similar, then their corresponding sides are proportional. And finally, we can set the cross products equal to each other. I know that this times this is going to be equal to that times that. So CD squared is going to be equal to AD times DB. And the reason is going to be in a proportion, the product of the means equals the product of the extremes. And that's it.